Section 31, exponential derivatives and integrals. All right, this is a really easy quiz section if you just know what's going on here. It's the actual math here is so simple because there's this cute cartoon I found on Reddit. The exponential function appears. He uses differentiate on it, and it stays the same. That's because the derivative of e to the x is e to the x. The integral of e to the x is e to the x plus c, because we always plus c. But, I mean, that's the special thing. That's why we care about this number e, which is the interest equation thing taken as x goes to infinity. If you remember what this is used for, this interest equation thing, it was continuously compounding interest. X is the number of times you compound interest. So if you do, this is like whatever your interest rate is up here. And you divide by the number of times you apply that interest in a year, so like 12 times. And you put a 12 up here to say, I'm going to apply this interest rate divided by 12 because I'm splitting it into multiple groups and interest rates are yearly, and I'm going to apply it 12 times and the money's going to get bigger. But if I do that infinite number of times, that's continuously compounding interest, which doesn't give you infinite money. There's a limit this thing goes towards, so this thing's graph ends up looking like this sort of thing where it like stops off and asymptotes, and that number it asymptotes to is our boy e, which is about 2.71828, which happens to be, because of this, the number whose slope, the number when the power is raised to the power of x, the slope is exactly the function. And so this is a really special number. It's why we care about natural log more than logarithms. In fact, how we do any sort of log or any sort of exponential in calculus is we convert it first to the easy one, e to the x or natural log of x, and then we take the derivative or the integral or do whatever. So it's like super important that you understand that e is a friend. E is not scary. E is absolutely something that is there to make your life easier. So let's just do some problems now. If the derivative and the integral, they're just the same, well, we're going to have u's and du's, like things of the exponents, so let's figure out how to deal with those. Okay, this one. We have 4e to the natural log of x plus e to the x plus 7x. Alright, so we know the first part of the derivative is just going to be to rewrite, because we always have what we started with in our derivative. Now I have to chain rule the inside in this case being the exponent, so I got to multiply by 1 over x, which is the derivative of natural log of x, plus e to the x, which is the derivative of e to the x, plus 7. Cool, that's it. That's the end of the problem. So the only thing that was really added here was there was a chain rule. Alright, next example. An integral one. This one's quite a bit more complicated because we got some u sub in this one. So you might notice our exponent has some nonsense in it, 3x squared minus 1. So let's see if we can get u sub to work. Hint, we can. We have this 11x on the outside, and that'll allow us to use u sub here. So u equals 3x squared minus 1. Du equals 6x dx. I don't have a 6x dx, I have an 11x dx. So I'm going to just solve for dx. Dx equals du over 6x. And I'm going to rewrite my integral now. The integral of 11x e to the u times dx is du over 6x. And plus, and here's where I'm like, sorry, minus, whoops, there's a minus there. I'm splitting it into two integrals here because I don't want to have like x's in one and not in the other. And I'm not like plugging anything in for the x here. So I'm just going to have this one be its own separate integral e to the x dx. Alright, now I can cross out the x's because there's one on the top, one on the bottom. So I just have 11, 6 e to the u. So if I integrate that, surprise, I'm just going to get e to the u. It's like so crazy. And this one's going to be e to the u. Whoops, minus. Or e to the x, rather. Because I just rewrite it for its integral. And plus c. And the last thing I need to do is just get rid of the u in the problem, so I just need to do 11/6 e to 3x squared minus 1 minus e to the x plus c. That's it. So integrals and derivatives for e to the x functions are very simple. You always, always, always rewrite exactly what the problem was in the answer. If you notice here, we have an e to the x and we have an e to the 3x squared minus 1. So the exponential part, e to the 3x squared minus 1, e to the x always shows up in our answer. Exactly the same. The only thing that changes is the coefficients. So here we had 11/6, here we had 11x. Over here, we have our chain rule part now. The exponential hasn't changed, we just rewrote it. But now we have different guys on the outside. And that's it for exponential functions. These are very friendly.